Good evening, everybody. So we are ready to start. My name is Dovydas, and welcome to Vilnius School of AI. Wow, this is the best one yet. So congratulations. Really happy. Today's our, I guess, anniversary meetup. It's the 12th one. We already done a full year. As you can see, we are not stopping for summer. We still have like enough people to go like all year long. And I hope that next year our meetup and our community will get even bigger. And let me tell you why we should get bigger. But before we do that, let's thank our sponsors, since these people, these companies, I guess, make this whole thing happen. So Tech Consult, Vilnius Tech Park, Code Academy, and Vinted, all of these companies helped our community in a significant way. And can I get like a round of applause for them? Amazing, thank you. Let's see what's on the agenda today. So first of all, we are gonna talk about what we accomplished. It's important to share the accomplishments. So, a lot of nice things happen during this month because we are meeting like mostly every month. And I really want to keep you updated about, our current state of affairs. Also real nice if you have something to share. So at this whole thing, this is not like a presentation. This is a meetup. So if you have something that you want to share, like you did some amazing AI, project during the last month, raise your hand and say, oh, look, Douglas, you are not the only one who does stuff. I am also doing a lot. So here's what I did. Right? Can we agree on that? Yay! Can we agree on that? Yes. Wow, to get that from developers is like basically as headbanging in a rock concert, I guess. So, what we are going to do today, what we accomplished, that's first. Careers in data science, the main topic for today, the presentation, about everything related to careers, not only AI, but in this like very related and a lot like overlapping field of data science. It's even bigger than what we call AI, because it encompasses like all the things which are data science but are not machine learning, which we currently understand AI mostly as machine learning. Finally, we do the most fun part, networking, where you can ask, me, myself, or anybody else here, and like we discuss topics. Usually that's the most fun part for me. Hopefully that's gonna be fun part for you too. So don't leave immediately after the presentation. We are here to like talk about AI and stuff. So let's start with what we accomplished. So the last month, we have continued to do our bootcamp. We have a few members today here. So if you want to learn more about the first-hand account of how we are doing this bootcamp, I think the first serious bootcamp in Lithuania about AI, at least I've been to one bootcamp, which was like 2 hours long. This bootcamp is 9 months long. So it's obviously impossible to learn AI in 2 hours. It's more realistic to learn that in 9 months, not guaranteed though. So it's very interesting how these people I haven't told them anything about only tell good stuff, don't tell anything bad. So if you want to learn first-hand accounts about our bootcamp, can you raise your hands to be targets in the discussion? Yeah, so these 3 people. So target them in the networking part. Sorry about that. All right. Then we are doing something else. We are participating in the conferences. So I have told that this one already, but still pretty fresh. I've been a speaker in the Login conference. Was pretty nice. Talked about AI philosophy. this is like personal. I am not working on AI philosophy, like about, you know, killer robots and stuff, but it's a personal, like very interesting subject for me. I like to have like this engineering side of my life and then this philosophical side of my life. They both happen to evolve around artificial intelligence. So I was more than happy to do this presentation on like a huge stage in the Login conference. Then I also talked about AI basics and like fundamentals of artificial intelligence and how that relates to the government role in SAMOS. That was pretty recent, I guess 3 weeks ago or 4 weeks ago, but it was like definitely before, like after our last meetup. So this prime minister, vice minister said that we are doing, like nobody in Europe has done this type of presentation that an AI expert is presenting, how to help AI startups and AI community in SAMOS. So Lithuanian government, I'm super happy that we are doing a lot in this field. They have like AI strategy, like national AI strategy. They have like very passionate people in key positions who really want to make it happen. The missing part is you guys. The missing part is people who are actually implementing the knowledge which they have and creating startups, or, you know, helping existing startups and helping in this, by doing that, helping the whole Lithuanian country. Finally, I am going to like a bigger AI conference, O'Reilly AI conference in Silicon Valley. I'm doing that in not the next month, but in September. So by the way, if you are also going to the conference, let me know. We can, like, I don't know, hang out. So let me know. It's O'Reilly AI conference in San Jose. So in the very, very center of Silicon Valley. So that's about the conferences. Let's talk about the workshops. We have started 2 new workshop classes, the F and D class. And I'm super happy that we finally have a lot of people in attendance. So, and like, in addition to having like lots of people, we also have, like, I have reworked and improved how the workshops work. So if you're interested in learning artificial intelligence for free, you can join our workshops. You will have like many more opportunities to do that, because previously the waiting list was like 3 months or something, sometimes even more. Now we have like many more opportunities to join the existing classes at the different levels if you're not starting from zero. So this is, I think, an excellent improvement in, you know, because we constantly want to improve the things which we do, and this improvement on the workshops, I think, is very important and will allow many more people to start learning artificial intelligence. So, by the way, if you want to learn more about workshops, let's talk about it during the networking part, and you can learn, like, I'll tell you more how to find all the information that you need. So, finally, the presentation, careers in data science. I guess this is the topic which you want, like, mostly to learn more about. This presentation was very heavily inspired by the course of the same name on Udemy. They're like this super data science team. That's their name. They're not like, this is not an epithet like super. That's their name, super data science. And they are doing like really, probably the highest quality courses on Udemy. Really key people in the community, and this is a nice non-technical presentation about how to be effective in getting a career in data science and everything related to this field. So also, in addition to that, I'm also sharing my own experience, because I'm like doing much more hiring like the last couple of months. So I know much more about this area, and can share like my own personal experience in my company, how we hire, data scientists and like more machine learning engineers, but it's in the same pot, a little bit more specific, doesn't cover everything what data science is. So are you guys excited? Yeah. Wow, very good. I see that at first you forgot how you have to respond, then you remember, so that's very good. So let's start with a hard question. By the way, I'm going to ask a lot of questions like that, and I want you like to actually answer them. I know it sounds insane, like how can you answer questions when somebody's on the stage asks them. So raise your hands if you want to see, if you know the answer, or if you want to guess, raise your hands. I want this to be like more than a discussion than a presentation, because presentations are boring, discussions are interesting. I can like much more understand what you have in mind, or what you like, what's your current like level is. So if you see something which you want to contribute, just raise your hand, right? Do we have a deal? Yay! Once again, do we have a deal? Yeah. Perfect. Let's start. So what is data science? Can somebody answer this one? It's actually like surprisingly tough one, right? What is data science? It feels like, you know, every definition, like we all kind of get what data science is, but it's not easy to get like a concrete answer. Data science is like, I don't know, machine learning is like creating machine learning models, putting them into production. That's like what machine learning is. What's data science? Totally different beast, right? So I was kind of surprised that I didn't find an easy definition, like a definition which makes sense for me. So the closest one was actually provided in the course, in this course in which this presentation is based on, by the Super Data Science team. So data science mostly does with creating added value on the field in which you're applying data science. It doesn't, like, you don't have to write it down, just think about it. But it's mostly like you want to add value. This is what you do in the day-to-day job. That's the most important thing. That's what's expected of you when you get hired as a data scientist. And it's up to you, how do you provide value. You can build models, right, doing the machine learning. You can pre-process, like build amazing pipelines to pre-process data, like prepare the data, engineer the data, like data engineer. You can even research new solutions, like create, I don't know, new recommender models, new computer vision models, self-driving cars. It's also part of data science. That's more AI or machine learning research. You can improve trust and safety, like flag transactions which are like malicious. Somebody hacked an account. You have your data science skills helps you to identify which accounts were actually hacked and prevent like stealing, like the hackers stealing money from the people. So it's all this whole thing. That's why it's so hard to tell the definition, because data science, the same thing as with artificial intelligence. Inside this name, there are like different stuff. It's not monotonous. It has different parts. And each of these different parts work a bit in a different way. All right, can we continue? Let's continue. So why data science is important? So adding value, that's, you know, that's expected out of every employee. Everybody should add value. Not only data scientists, like whatever job you do for a company is for your added value. Nobody hires you for, you know, sit around. So what exactly the data scientists, what do they do that's special? Why data science is such a important and promising field, also interesting field to work in. So what can be ways that you are actually helping your company? So pretty obvious ones is extract insights. That's like mostly when you think about data scientists, most of the time we are like thinking about business analytics or data analytics, like people who get insights from the data, who help businesses to make decisions. The second one is optimizing processes. That's more in the realm of engineering, sometimes data engineering, sometimes machine learning engineering, something which helps the company to do something. Like previously we had to hire, I don't know, like 100 people to do customer support. Now we can hire 12 people, but we like have a very good algorithm which like replies, which selects the actual messages from our FAQ and like reduces the actual load on our customer support. So we can optimize various different processes using data science and like models. We can use data science to give a competitive edge. This is mostly like this one mostly deals with the new newer fields in data science, mostly deep learning. You cannot do computer vision competitively using anything else except for deep learning. If somebody is using deep learning and you are not using deep learning, that's it. They win. There is no, you cannot compete with that. So this gives you a competitive edge. If you're a new startup, you can beat like giant companies, entrenched companies, if you're using the new correct algorithms, new models, basically deep learning. And finally, I want you to think about the data as the oil or the blood of a company. As with the data, you can do a lot of stuff. It keeps you alive. You can get the vitality and the health of a company by checking, you check the oil of your car, or you check the blood of yourself, and you get like various metrics, right? And that tells if you're healthy or not. So data is the same thing. It's the blood which helps you build stuff. Also the thing which keeps you alive. Also, if it's bad, it kind of tells you in advance that company is not going the right direction. Gives you advance warnings before you don't have to like die. You can take action for like preventive medicine. So I guess I convinced myself that data science is pretty important, right? Have I convinced you?
Yeah, I guess.
Right. Do you have any questions? By the way, just reminding you, if you have questions, ask them anytime. Just raise your hand. Say, I have an example like why data science is important. That's why, right? So don't forget that you have this option. What does the data scientist do? And this is absolutely not the only thing which data scientists do. Just I wanted to give you an example. So mostly doesn't matter what part of data science you're working with. Be it machine learning, business analytics, data engineering, doesn't matter. You always have to identify the question. You have to be very sure what you are actually doing. What are you trying to achieve? So identify the question. Do you want to prevent fraudulent transactions? Do you want to have the best recommender? Do you want to have clean data? What's your purpose? What's your goal? What's the question? Then, pretty much always, you have to prepare the data. It's the tricky part of data science, that it's always about the data, and you always have to prepare the data. It's never seems never to be fully prepared, because we all wish that this would be true, that you get everything neat and tidy, like you get from Kaggle competitions, that everything is in a row, in a table. Just have to apply your magical deep learning skills, and wow, you have a model. In reality, data preparation mostly always is the bigger part of the job. I'm not saying that data preparation is not fun or it's bad or something. Data preparation actually is mostly programming. It's building pipelines which you input the data, because data usually stays in the same format. So you build a pipeline which gets the data, does a lot of transformations. Finally, you end up with the type of data which you can use for your model. So mostly when I was learning about this machine learning, always we said, oh, data preparation, it's such a big part of the job, and it sounded terrible for me. I was imagining, manually labeling, pictures like, this is a picture of a cat, this is a picture of a dog, this is a picture of a car, and like I imagine myself typing these, labels myself. In reality, it's not a thing. It is a thing, but data scientists usually are too much paid to do this type of thing. There are services which actually do that, data labeling. So usually if you are working especially in a bigger company, you don't have to do that yourself. You can hire people to do that for you, or sometimes it gets outsourced to like technical support department or something. People come up with ways to deal with it, but usually as a data scientist you don't have to do that yourself. Sometimes you have to do manual data labeling after your model trains on million images. You get 200 wrong, you check out the first 10 and you see that they are mislabeled. Like your model was correct, but the labeling sucks. So you might think, okay, I can label like 200 images in like 20 minutes. It's not a big deal. So it's better, to do that yourself than to organize the whole thing, like send the data to external services or something. So that's data preparation. Analyzing the data, almost always the step involved. Again, doesn't matter what you do, you have to understand what the data, like what does it look like, what's it's all about. So in order to prepare it, or even after you prepare it, you want to know what that is. So is it categorical, is it continuous data, is it high cardinality data, is it low cardinality data? These data analyzation decisions they kind of are required before you do anything else. So after you analyze the data, you usually want to visualize it. Not always, like machine learning, not always does a lot of data visualization, but mostly, like for most of the other parts, you are visualizing the data. So visually, it's much easier to see how you did. Finally, you present your findings or present your solutions. That's when you build the model, you have some results, present them, you show like, okay, we have this insight, or we built this model, but it doesn't work right? We detect, criminal or not criminal only like 50% of the time. Let's not put that into production. Americans do it anyway. So you know about the controversial decision, which has like a very high false positive rate that people are not criminals, they get identified as criminals. It was in like a famous topic like a month ago or something. So check it out. So it's up to you as a data scientist to see like, look, we don't have enough data, we don't have enough confidence in the model to put that into production. So that's part of your job. It's not only for the data analytics person to present the findings. Doesn't matter what you do, you still have to present the insights about the model because you are the person who understands how it works. Sometimes it's as easy as just presenting the findings. Sometimes you have to do more, present the findings and deploy the model, present the findings and like do the research paper. So it's a lot of other stuff, but usually these 5 parts are what's always happening. By the way, is it just me or is the microphone like very noisy? Sorry about, I don't know how to deal with it. Maybe now it's better. Yeah, anyway, so that was what the data scientists do. Let's see what everyday life of a data scientist looks like. Obviously, this one depends on the role. Now we are getting into the parts. Their data science starts to show that it's not a monotonous field, that it has different parts which work in a different way. Building and experimenting with the models. From what you already heard, what do you think? Who does that? That's an easy question. I'm baiting you now. No tricky part, so that you learn that you can answer me. If you know the answer, raise your hand. Again, not a tricky question. What's the name of the profession who builds and experiments with machine learning models?
Data science.
Data scientist, good guess. More specifically, like there is a more specific name.
Machine learning.
Very good. So machine learning engineers usually build and experiment with the models. More names, like sometimes they are called deep learning engineers if they only build deep learning models. Sometimes AI researchers if they like do more research with the models than actually wanting to like put them into production. But usually some kind of engineer, usually not analyst. Who do you think researches new solutions? I hear analysts, not really. What else? Researchers, very good. Actually, correct answer, because it's again a lot of names, like sometimes AI researchers, ML researchers, whatever else. We have like sometimes even computer vision researcher. If you only work with computer vision researcher, that's totally legit. So if you're more into solving problems which haven't been solved or which haven't been solved for the type of data which you have, more a research type of job. Usually like companies have like these separate research teams which do like research. In this one, it's also included building tools. Like strangely, like from what I understand, like if you're building, let's say Tensorflow, you're still a researcher. You're not, because probably you have to like understand very good how like these different parts work, so you can build a proper framework. It's important, so it's still part of the research. Finally, extracting insights. Come again, please?
Analysts.
Very good. Analysts. So usually business analysts, data analysts, those two. I don't think there is such a thing as machine learning analyst, but there might be. Like there's like these combinations, they are very like anything mixes with anything, you get a new profession. So data analysts or business analysts get the insights from the data. Doesn't mean that we don't build the models. Doesn't mean that we don't do research, but the main thing which we do is extract insights, help to steer the project in the right direction. Let's see how many roles have we guessed correctly, or how many roles have we mentioned yet. So business analyst, we mentioned that, mostly does data mining, A/B testing, and reporting, like creating dashboards, stuff like that. Data analyst is much more coding focused, like they should have like stronger coding skills. Usually that requires some programming language such as R or Python or Scala or Spark to do this one. Much more, you need more also statistical knowledge to do this one. Sometimes you have to create models, and it's basically like usually viewed as a next level above business analyst. So business analysts usually, again, not always, sometimes business analysts are like very, like very high in the corporate ladder, but usually like in most of the companies, data analyst is like the next step above business analyst. The next one is data modeler. So this one is like in like larger companies, you have a person specifically for like modeling of the data, and like usually you deal most with models. Sometimes this one includes the machine learning, deep learning engineers. Sometimes that's included like as a separate thing. Sometimes that's included as a data scientist. So this one has some overlap with the data scientist, which is the next one. Sometimes not. Sometimes it only deals with pre-processing, like data engineering. This is, you see, we start to get like messy now because there's no clear-cut ways to divide that. So that's we have to work with that. Then we have data scientists. So this one includes usually the machine learning engineers. The most of the things which we talked about, that's the general data scientists. Kind of, you can imagine that this one expands. This one should have like a button. You click here and it expands in all different flavors which the data scientist can have. Finally, data science manager, the person who makes the whole data science project happen. The person who is usually more experienced, the person usually who has like a track record of delivering the project successfully, can be also viewed most of the time as a next step above the data scientist. It like in my company, we have like these different tracks. We can have like leadership track or engineering track. So if you're a good engineer, if you like reach a senior level position in our company, and it's like more difficult to reach than in other companies. If you reach that, you can choose to go work more with people, like leading other engineers, or you can like become like super engineer, staff engineer, how we call them. And these staff engineers are like really experts, community level experts in their own field. So this one is, if you're a data scientist, you can be like very like super strong expert, best in the world. If you're a manager, that means at some point you chose to like scale yourself and to help out others to be to work better than to do everything yourself. The requirements. So I hope I sold you on that it's so fun to be a data scientist. Let's talk about how to get there. By the way, what do you think if I just talk without the microphone? Because it's kind of annoying for me. All right, let's do that. So what are the requirements? How do you become the data scientist? You have to have skills. Who knew? And the skills might surprise you, by the way. Who was expecting like a list of programming languages or frameworks? Wow, most of you. So really, it's not all about the frameworks. Frameworks are important. That's, you see, programming. It's not the only thing. Remember the first definition of what's data science? You have to add value to your company by applying data science. So this field, kind of, if you can do amazing things using just Excel, that in my eyes is enough for you to be a data scientist. You might be like an Excel like best girl or guy in the world with Excel. You can do insane things with it, and that's enough for you to like deliver a lot of value for your company. That would say like perfect data scientist. Usually that's not the case. You have to have like corresponding technical expertise, but you also have like to have like these different other skills. Communication. Why do you think that's important?
Because you should communicate results
Very good. Imagine you are building like a model which detects cancer. And you cannot detect like some types of cancer, but your overall accuracy is like 95%. The best doctors in the world can detect 92%. So your model is better, and it's automatic, so you don't have to hire the best people in the world. On the other hand, if it cannot detect this type of cancer, you have to be very sure that your presentation says that. Because otherwise it's, like criminal negligence, you can say. So it's always like, doesn't matter, again, not only data analysts have to present their findings. You are presenting and you are communicating every single day about your models. You can be an AI researcher, but you better communicate if there are like dangers in your model. You better communicate if you don't know something about your model, if it behaves strangely in some circumstances. So this is why it's number one. Communication, super important, everything you do in this field. What about the second one? Presentation. Very related. So these two go hand in hand. In addition, some professions such as business analyst or data analyst, that's their main thing. That's their presenting is their most important skill, because you might get the best model, but if you cannot present that to the CEO of a company, or you're presenting it in a not intuitive way, you're not achieving your goal. So you can say that should be under communication, but that's decided to leave it as a separate thing. They're related, sometimes the most important thing, not always. Domain knowledge. What about this one? Usually it's like a funny thing that the more you know about how your company works, the better data scientist you are, in a way that you can, first of all, think of a new insights, like we are doing this way. What about I use my machine learning skills to do it in the same way, but 10 times more efficient. We had to hire a lot of people, now we don't, because the model can do that for us. Or we used to track fraudulent transactions manually. Now we can flag them all automatically. Saves us maybe not saves us a lot of people, but it handles much broader range. We can check many more transactions. What about real life practice? That's might not be super clear what I mean here. So mostly I mean you have to have experience how to use these models in production. So if you have lots of theoretical knowledge, that's usually not the case, because there are lots of specific things about data science and putting models into production that you have to know to have them tested in real life. So this is the thing which obviously you can get real life practice only by practicing in real life, but it's also a very important skill to have. Getting everything, you can see everything as a multiplication. Your communication multiplied by your presentation, domain knowledge, real life practice, programming, and creativity. You get a score. If you are 0 at any one of those, you are the 0 overall. But if you are not super strong in one area, you can always compensate in a different area. So what about programming? That's pretty clear. We are going to talk about programming quite soon, more about programming languages and stuff. Obviously that's important. That's expected. This is the one which we all expected to see. Finally, creativity. Why do you think that's important? Oh, yeah. You have it.
To be able to think out of the box, not inside.
True. You have to a lot. This field, it's quite new, and it's the type of field there are no something which was true 2 years ago might no longer be true today. people said that, look, we had to have, like, there is no way to have neural networks deeper than 16 layers because we don't train anymore. What do you know? 2 years later, we have neural networks which are basically unlimited. You can build a model, like you can build a neural network which is like thousands of layers long, because creative people figure out a way how to do that. The math didn't change, the laws of physics didn't change, but something which was thought to be impossible with some clever application became possible. So there is no way for the gradient to move down the chain. Let's not move the gradient down the chain. Let's provide a shortcut. Let the gradient move like in a huge step right back to the beginning. So we saw new things. We don't like violate math, but sometimes it feels that we do. Sometimes they feel like magic, like something that was fundamentally true now suddenly becomes not so true anymore. So creativity, this field is like particularly interesting in this creativity field. Sometimes bright ideas like dropout and like batch normalization, they come from the real life. They come from like people who just observe real world and say like, what if I use this idea in like machine learning? And bam, we have like groundbreaking solutions. So creativity, very important. The branches of data science, we have data mining, databases and processes, machine learning, statistics and visualization. These are mostly like these more granular fields in which you can find yourself in. No, I don't want to like spend too much time on that because we spend a lot of time on the first part of the presentation. So just remember, like we have like these branches of data science. More interesting question is, should we have a master's or a PhD to work as data scientists? What do you think?
No. The name itself says something.
Importance of masters and PhD. So who thinks that we don't have to? We might have to, it doesn't hurt, but we don't necessarily have to have it. Who thinks that we must have like at least a master's? Right? Like seriously, nobody else? You will all not get hired. No, I'm kidding. I think that you're like, I'm on this, obviously I am, as Vilnius School of AI, guy who thinks that we don't have to have a master's and a PhD. Unfortunately, or I guess fortunately for like my company, some of our competitors think that you do. And we get like sometimes you can get smart people who don't have the certificate, but they are like, I don't know, winning Kaggle competitions from young age, and they wouldn't hire that if their corporate structure, all the hiring mechanism says that HR person first checks if the person has a master's or PhD, removes everybody who doesn't. You won't even, pass the screening. You will never get, your CV will never get viewed by a person who has understanding what Kaggle is, and that winning Kaggle pretty much means that you are kicking ass. It only means that maybe even a robot will just delete or archive you and send you a polite letter that we have chosen another stronger candidate for this position. So this certification is helpful to pass the initial stages. After the initial stages, it doesn't mean anything. After the initial stages, it's all about your knowledge, your experience, your ability to actually deliver. And most of the companies, survival of the fittest. Most of the companies who view it in a different way start to either rethink their hiring practices or start not to expand so much. If you know what I mean, like if you're not expanding, that means what, you're like slowly dying. So this is what like currently goes into fashion in the hiring of machine learning engineers. Masters and PhD helps you, especially initially, then their importance drops sharply. So you actually don't have to, having a PhD is not enough anymore. You have to really know your stuff. Does that make sense? All right. So let's move on. Let's talk about the minimal requirements. What do you have to know to be hired or to like have a chance in getting hired? Again, this might be surprising for you. No 5 years of experience, no 5 projects which you have under GitHub, no like, I don't know, Kaggle win or Kaggle top 200 in your country. So I think that you have a drive, passion, inspiration, whatever for this field, it's a big plus. If you don't have any particular knowledge, let's say you don't know how to code, can you still be a data scientist? Doesn't help, obviously. This is a big disadvantage, but you can find a business analytics role and then grow from there. If you're a kick-ass business analytics, don't worry, you will get noticed. If you truly are good, you will have like unavoidably, you will grow, you will become like data analysts, data scientists, and later even, I don't know, like data science manager. Probably in most of the companies, like at least I'm sure like in Vinted, you cannot do that without learning how to code. This is a requirement. You have to be good at coding to be a manager, like a team lead. But in some companies that might not be the case. On the other hand, coding is not something which you cannot learn. Everybody can learn how to code. So if you're really passionate about it, that's, you know, like learning how to write was in like 300 years ago. The same thing applies. So just go and learn. There are so many ways to do it. One of that is AI workshops. Also, that's funny, any background works. So you don't have to have a very related field practice to go to data scientists. That's what's good about being better. If you know a lot about this field, you can be of a great help to like especially a startup where you have like 5 engineers and you're the only one who knows like this cancer thing or this, I don't know, actual logistics thing. You want to build like a kick-ass logistics machine learning platform and you are the only one who knows logistics, but you know like not a lot of coding, not a lot of data science, but you still can help, especially if you are passionate and you are willing to learn. So passion, thirst, find if you have like some limitations. Obviously, knowing how to code is a great help. Knowing, you know, statistics, great help. This practical knowledge is super important. I just want to say that we are not, like you can even bring a case where you can do that without programming. That's the most extreme one which I can think of. So you can do that anyway, especially if you have like this first one is not optional. You have to have it. If you know, yep.
Just a small comment. I would say about the coding. Big corporations like Amazon and Google are doing their best to make coding optional in their products, so to speak. So essentially, if you would be a data scientist who knows the domain and you know how to model the data, you can start using Amazon Sage.
SageMaker.
Yeah, SageMaker, and then you can start doing stuff.
Yep.
So
Excellent comment. Yeah, you don't like Vera. Pretty much what he said. Excellent comment. I guess if you are like a master of all these online tools, you can even argue that you are adding more value to the company than somebody who's like, mediocre coder who doesn't, just wants to get the paycheck. So if you're like passionate and say like, I know these tools, I know SageMaker, I know Google, like ML platform, I can, only drag and drop, but that's enough. Costs a little bit more than to run on our servers, but who cares? If you can like bring the sales 10% up, it's like 1,000% return on investment. So it doesn't matter if you pay $5 a month or you pay like 500. It's it doesn't scale this way. So how to become a top data scientist? Unfortunately, you have to study. So to be good at something, it's not enough to be born. You actually have to try hard. And obviously there's like different study path for each of the destinations. Remember, destinations are, do you want to be a data analyst? That's one path. Machine learning engineer, different path. AI researcher, yet a different path. So all of these paths require different, all of these destinations require different paths to study. The technologies also differ amongst companies, so you cannot, only study R and expect, I know R, I can be like a super good data analyst because everybody uses R. You might go to a company which says like, we are only using Python or we are only using Scala. We have like so much data, R is like not really cutting it for us like Spark, and everybody has Scala because that's how we started, and now we are pretty much have like million libraries which are built on Scala, so you better also know Scala because otherwise you won't be able to help. So technologies, that's a good thing because it doesn't matter what you choose. Even if you choose the most wrong thing, you can probably still find a company which uses that. This is why the last point is so super important. If you pick something, you better stick with it. If you picked something like you learned like 3 months later that this was not optimal, I would say it's better to stick with it and continue, and then change. Like let's say you picked R, right? Learned R, very good. Turns out everybody in machine learning uses Python. You didn't know that. That was somehow not told previously. So what do you do now? I would argue join a company which uses R and get a job first. Then on your spare time, learn Python. Say like, guys, I know Python now. I can be a machine learning engineer. You already know me. You already know that I can, kick ass. I am doing a great job as a business analyst. Let me try this machine learning thing. So that would be my opinion, the best way forward. Obviously, the other one works. Just the bad thing if you become some person who always hops from one thing to another. You're learning R, now you're learning Python, now you're learning Swift because you heard like Swift for TensorFlow is a big thing. So if you're hopping, if you're changing your mind like twice, you know that that's it. You have to stop. After you changed like once, that's it. You only have like one change, and then you must have a job. So that's obviously my opinion. I'm pretty sure that like lots of people who violated this one, but I think they kind of made this way suboptimal. I want to present like machine learning path because I talked about paths. This is what I think the machine learning, if you want to go to the machine learning side of things, like deep learning, computer vision, natural language processing, artificial intelligence, whatever, pretty much all of these things are a must. So first, Python. You can do that with R, you can do that with Spark, Scala, whatever. Python is the best one so far, choose that. Numpy and Pandas, Python turns out is not enough. You have to have something on top of it because Python is super slow, doesn't know how to work with numbers in an efficient way. So these two on top is a must. Matplotlib, at some point you have to visualize something, so you have to know how to make charts. That's Matplotlib. Scikit-learn, that's the classical machine learning. Everything has an amazing API. For such a old project and such a huge project, they are iterating phenomenally. They are changing their API. They are moving fast, and they are doing like that in a, I would say, very nice way. So their API is amazing. They're like building decisions. API decisions are very good. This is why everything that comes after scikit-learn copies at least parts of it. So this is why learning scikit-learn is amazing, because it will give you insights about everything what's next to come. The last one is optional. So if you really want to go to deep learning, you have to know either Tensorflow or PyTorch. Previously there was like more candidates. Now it kind of is, the ring is only like 2 boxers are only left in the ring, the 2 fighters. Everybody else has died, been killed by those 2. So it's that or that. At this point, I hear that they're like neck and neck. It's very hard. Like previously, TensorFlow was like much bigger, but PyTorch is catching up so fast. And at least in the research community, I think it caught up already. In the production environment, in the companies, it's not yet there. It's not there yet. TensorFlow is still like much like dominant in actual work environments, but mostly it follows the, I think that it will follow the lead of the research community, and like PyTorch will expand in the actual applications in the like companies which build products. So these libraries, technical skills which you must have. The other skills which you must have, the non-technical, like library stuff, is data preprocessing, data engineering, modeling, deployment, monitoring. This is how you build a model. You have to know each part. If you're like very lucky, you join a company which has like deployment like set up for you. You don't have to worry about deployment and monitoring. You have like people who do that, like a team, server reliability team who does that for you. So if you're lucky, but to be like a full-rounded person, like data scientist, you have to know everything at least in a theoretical level, especially like if you want to join a smaller startup, then you will have to do everything, and you better be ready to do these last parts because they are like super important. It's not enough. Your job doesn't end when you build a model in a notebook. Let's talk a little bit about programming languages. We already mentioned Python. I already mentioned R a couple of times. Also Scala and SQL. By the way, can I get like a raise of hands who know any of those? Mostly everybody who haven't yet started to learn programming. Okay. So good, like most of you know something. Who knows Python? Who knows R? Pretty close. I see like some people know both. So that's very good. You're well-rounded. Who knows Spark and Scala? Also a few people. It's very good. So you're perfectly well-rounded to do data science. These programming languages, I kind of say that they are in this order. If you want to get a job, like easiness of getting a job, I would say it goes this way. Easiest with Python, because most options available, especially machine learning, mostly is dominated now by Python. Business analyst, data analyst, this one is like a tough fight. I think R is on top on this one. Scala, especially with like big data and like previous limitation on Spark that it only allowed Scala, so it was like the only option. So a lot of the companies who have invested in their infrastructure a while ago, like they have this like requirement, you have to know Spark, not only Spark, it's much better if you know also Scala, because this is how like every single notebook which we have is built, so you also have to know that. Finally, SQL, that's I guess the old school one. Not enough probably to know only that, but yet again we can argue a case where this one is just knowing this one is enough. Now I guess it's like a bit superseded by like if it's a big data you would use Scala Spark. If it's like machine learning, you don't have to deal with SQLs too much, you just check images. We are not in a database, we are like on a directory somewhere. So this one is more optional, that's why it's the last one. But it is an amazing addition to any of the first three. If you know any of the first three, also learning SQL, very big improvement. Like doesn't matter where you end up in the scale of like machine learning, researching, business analytics, it helps out everywhere. How to get practical experience? I guess most of you haven't yet started working as, by the way, who is here working as a data scientist? One of the flavors. Yeah, only a few people. So how to break into this field? Because you need, real life experience. How to get that? Personal projects. Projects is the single most important thing which you can do to improve your success, because that's how you learn stuff. If you're building enough projects, there is no way that you are not learning. It's pretty much impossible. If you're watching videos, if you're reading books, doesn't mean anything. If you can do project, that's defining factor. You can do project, that means you can do the same project or bigger project inside the company. Might be more difficult, but still all the same steps apply. Yep. Good thing that I have it on a watch. So. Thanks.
It's no longer recorded.
Sorry?
It's not longer recorded.
Let me fix that. How unfortunate. So the recording died, doesn't matter. Let's continue. We have like a few slides left. How to get the practical experience, personal projects. Also, what I haven't thought and what I've picked out from a video, from a course, you can do the projects for your local company. Let's say you work as anything, as a driver. You can still do a project for your current company because you have access to the data most of the time and you have access to the domain knowledge in this field. You have to have something. If you work as a company, you have to know something. So an amazing option, use it in your school, university, current job, because that's going to be much easier to get the data, much easier to get practical experience. Maybe you will get, upgraded to a data scientist. So that's one thing which you should always consider. Just take initiative, do whatever, learn what you have to learn, do a project inside your company. Also, always an option, repurpose your existing experience. Let's say you're a web developer, show off that you have this programming skills, which are very important for data scientists, especially in the engineering part. Show that you are very interesting, very interested in like making the code good, that you have like statistical knowledge, maybe in the university. So you add these things together, you end up as a data scientist on paper. Obviously, you have to learn like new skills, but don't throw out your existing experience out of the window because it might be relevant. So finally, the top data scientists. This is again from a video, but Super Data Science team considers to be a top data scientist. Funnily, the first one is a little bit crazy. I really like this one, so I left it in the presentation. And you see these whole things, like these come back to the first, creativity, programming. Remember that slide? So this one kind of very encompasses the whole thing. The last one is interesting. Be proactive and take initiative. That applies anywhere, but very important in the data science, because you might know that you can build like a machine learning model for something which nobody yet thought about. Maybe a lot of the people, like your managers, don't even know that you can use your knowledge to make something which it might not even come to their mind, that you can do a self-driving car. Obviously it came to people's mind because that's the first thing which we think of, but let's say you can do emotion detection. It's pretty easy to do, like million images of people smiling, million images of people frowning. You can do that in your company, I don't know, for whatever reason. Like let's say tracking the audience. I can build here a tracker, scan all of your faces and see if people are laughing. That means on my screen, it's you're doing great on this, good example. If everybody is checking their phones, go to the next slide. So let's go to the next slide. Job options. So what type of jobs can you get? These pretty standard, the same as with regular programming, employee, contractor, freelancer, regular stuff. I would say in this field, more employee, Lithuania is notoriously anti-contractors, but in this field kind of specifically because you have to pass the data around. It's quite difficult for companies, especially with the GDPR, to give somebody else data. And even if they could, there are extra limitations. Let's say you are a contractor, I want to put the data on Amazon Cloud. And they say, cannot do that. Must stay in the European Union, in some of our providers. And you only, as a contractor, you're using Google, Amazon Cloud for everything. So there are a lot of different cases which, if you are an outsider, which kind of hurts you. And when you end up with the final cost, might cost the company the same amount as hire a person for a year as to do one project with you for a month, if you add up all the costs. On the other hand, on the other end of the scale, sometimes the local talent is just not available. Especially in Lithuania, we have severe lack of local talent. So sometimes, for example, Vinted. Even our team, we have a consultants which help us out in some problems, so we are not stuck for a month figuring out stuff on ourselves. We have contractors which have much more experience in this field, help us out jump above these obstacles and do these things for us. It costs a lot, but if you can build products faster, that still pays out. Still, return on investment is very good. So, types of jobs, again, yet again, not a list of get a job and in Facebook or Amazon or in I don't know, Vinted. Think about what you like. Think about what kind of work you want to do, and do what inspires you. Finally, last section. Promoting yourself. So always not easy to get the job if you are totally unknown. So first step, pretty obvious, get a CV, right? Second thing, I thought that was obvious. Turns out it's not. Cover letter. Sometimes the cover letter is not required. It's always a good idea. I mean, as a hiring manager myself, I read all the cover letters, and I like when people like, oh, I want to work at Vinted because look, you guys build stuff which I like, you care about the world, you care about the environment, it kind of drives me, so I want to like be part of your team, even if I like don't have like that much of experience. I kind of like this person immediately because they took time to like think, like tell me about that we are not here for the salary. They care about the problem. They care about what we know about us. We know that we do this type of thing. So cover letter, also a good idea. Very easy to make. Make one for each the CV you send. Doesn't have to be a separate file. You can just write in an email or whatever, how you are sending your CV. Third one, blog. If you are interested in this thing, this one is like the next level, really stepping up your game. If you have a blog, I mean, like when you're learning, you have like a lot of time on your hands. Imagine that you are creating this blog for yourself. Like how the easiest part to make a blog. Imagine you are only blogging for yourself 2 months ago. What you learned in the previous 2 months, you are putting on a blog. And there are like so many other people who are in their learning journey 2 months behind you that this approach works the best. I mean, if I'm like a year ahead of you and I'm putting stuff, I'm providing too much information. You are not relating to the challenges which I have. I might be saying, you know, how to scale the machine learning, like deep learning models with this extra super large data sets. That's what's driving me. But it might not be driving you because you're creating your first deep learning model. You only care about like what's an optimizer. So imagine that you're blogging for yourself. Easiest way to create a blog. Not hard to do, like sign up on any platform. Doesn't matter what platform you use. It can have like insane name, like something.wordpress, something. That all works out. Portfolio. This one is also hard. For some people, this one is easier. For some people, blogging is easier. So they are kind of at the same level. If you have portfolio of previous projects, that's amazing. Always an advantage for you. Because if you have a portfolio of like computer vision model, you can always have, you know, like I'm building a computer vision team. Amazing benefit for me because I already know that you know the basics. Like whatever happens, if I meet you on like the first introduction talk, I already know that I'm not wasting my time. Worst case scenario, you don't pass other tests, but if you have a like portfolio, immediately you jump to the top of the list. Finally, Facebook groups. This one is like the weakest one. So if you're like active on a community, also a nice thing for you, like a bit like a blog, a bit of like just sharing your knowledge with other people. You're showing that you have like a bit of like leadership skills and a bit of like teaching skills. Also a nice thing. So if that's your thing, also do that. You know, Facebook groups, Stack Overflow, whatever. I just kind of didn't expand that, but it's any question answer type of thing. So, that's the actually last one, the interview. So what kind of interview questions should you expect? What do you guys think? Who has been to the like interview recently? Nobody? Okay. Oh, Laura, tell us more. What was asked?
Strange questions from recruiters.
One example? Like just one example, that's all I ask.
It was more about Python.
Uh-huh.
Programming language. And the expected question, what is the cross join?
Okay.
For instance, yeah.
It's more, I guess, SQL data like skill.
Semantics.
Yeah.
Related to Python.
Yeah, I remember. We talked about this one already. So yeah, questions vary very much amongst companies. By the way, secret, companies don't know what questions, like what good questions are. Kinda you want to just talk with the person, and then once you're talking, you kinda notice the small, like if you make mistakes in some areas, you'll automatically pick up these small disturbances in the force that they don't know what's like overfitting. Like a lot of people don't know what's overfitting. A lot of people don't know, how to like pre-process the data correctly. So you pick up all these things, but if the person knows like all around mostly everything, you can get a pretty good idea of what your skill level is. And if you get like a lot of red flags, doesn't matter, the actual questions which you ask, it's more about, as reading body language, so you're trying to read the person. And so that's from a company perspective. From the employee perspective, kind of if you know that, I guess that helps you a lot. You don't have to overthink each and every question, because even if you think that I have to answer everything, and you answer everything, but you make, these subtle mistakes, it's even worse, in my opinion, than, to say, I don't know, I'm not like good at this thing, and then acing everything else around the board, or even having, this like skill gap, let's say, in deployment. I don't know deployment, let's say, but I know how to build models. So if I answer every single question about model building, I can assume, like as a hiring manager, I can assume that you know your stuff with model building and you don't know deployment, but we have a guy for deployment, so no problem. So always keep that in mind, that it's not always cut and clear that you have to answer questions. It's more about this, more subtleties about really showing your strengths rather than just robotically answer the questions. It wouldn't be like impossible or inconceivable that you say, look, I know this thing like very well, let's talk about like computer vision. Don't ask me questions about cross joints. I don't care about cross joints. I never used cross joints, but I'm the best person in the world for computer vision. Let's talk about that. Does that make sense? I mean, in good companies you can do that. In bad companies, you don't want to work there anyway. So if somebody said, no, I have like 5th question and we are 5 minutes late, so you better answer what's a cross joint or you are out of here. So you don't want to work there anyway. Finally, networking.
What are big questions?
These like out of the box thinking, like what would you do if you are in, like how many windows there are in New York City? So these used to be popular previously. I left them out as the guys talked about it in the course, but I personally never been asked this question. I was waiting in so many interviews, oh, give me one, I will kick ass. But never been asked, so I guess not that important in Lithuania.
I got the question, how many people are using now the trolley buses in Vilnius?
All right, let's do that over networking. So thank you all for coming. I hope that you enjoyed this presentation. I surely enjoyed giving that presentation to you. And please stay for networking. Let's discuss all what we heard today and more. So thank you all for coming. See you next month. And thanks for being a part of Vilnius School of AI.
Vat jie bus kažkada organizuojami, kaip čia bus? Irgi parašysit internete turbūt viską?
Jo, viskas bus įdėta į Facebook'o grupę. Šiuo metu mes tik pradėjom dabar 2 naujas klases. dar kažkur, nežinau, plus mano konferencija labai greit artėja, tai greičiausiai bus spalio mėnesį kitos grupės renkamos.
Gerai, ačiū.
Prašau. Taip.
Aš irgi paklausiu, kur galima rasti daugiau.
Jo, tai kaip ir sakau, mes ką tik pradėjom. Taip, dabar workshopai. Kas norit apie workshopus žinot? Prašau, tai visi čia ateikit. Taip, tai workshopai mes tik pradėjom praeitą šeštadienį, prieš kiek čia, 3 dienas, pradėjom naują workshopų tą iteraciją. Pradėjom vieną F klasę ir vieną D klasę, tai visiškai beginnerių klasė ir žmonių, kurie turi Pythono pagrindus ir dabar mokosi data science. Tai jeigu jūs esate, pavyzdžiui, patyrę programuotojai, greičiausiai jau galėsit prisijungti prie mūsų spalio mėnesį. Tikriausiai spalio mėnesį bus nemažai vėl naujų iteracijų, gal netgi būtų ir šiek tiek anksčiau, bet aš pats, kadangi būsiu Amerikoje tuo metu, ten visą mėnesį beveik, tai nestartuos tos workshopų grupės.
O kaip ten procesas? Ta prasme, žmonės gauna užduotis, po to ten, sakykime, kartą per mėnesį susirenka, ten, kaip tai vyksta, kaip norėjau paklausyti.
Tuoj parodysiu. Geras labai klausimas ir kadangi turiu atsakymą, tai noriu parodyti iš karto. Tuoj išjungsiu tik tai filmavimus.